Hello, everyone, and welcome to another episode of the Top Cyber Pro podcast. As always, I'm Jim West, founder and CEO of TopCyberPro.com. I have a wonderful guest today, and I'm just going to immediately turn it over to himself to introduce himself and tell us a little bit about what he's done across a long and very impactful career is where I'll leave that at. So I'll turn it over to my guest.
Thank you, Jim. My name is Tony Hassel. I'm from the northwest of England, but I currently live in North Wales, which is a great part of the world, I've got to be honest. We're right next door to Snowdonia and all the castles. And although people don't think of us having good beaches, we do. We really do.
I think
So,
the one place I went to in Wales was I think called Holyhead. Is that the
Holyhead,
Holyhead?
Holly,
Holyhead.
that's where you get the boat across to Ireland.
Yes.
And there's a lighthouse there just down the coast
Mhm.
called South Stack. Did you get the opportunity to
I
go to
did
South?
not. I was kind of exploring more like the valley before the mountains, but I do want to go
Yeah.
back to Wales. It's beautiful country.
Oh, good man. Yeah, you were on Anglesey. That's where Holyhead is. So when you're on Anglesey, when you look back to the east, you see all of Snowdonia, or as it's known in Welsh, Wydfa. That's they've we don't refer to it as Mount Snowdon or Snowdonia anymore. It's given its original Welsh name now. So, and anyway, back to my my origins really. I began as an apprentice electrical engineer working with my dad. And that was a long time ago. It really was a long time ago. And one of the jobs that I had was putting together the drawings of the relay control systems that we basically built to control all kinds of equipment. One of the first jobs I ever worked on when I had to basically produce drawings was a factory that made what we call crisps, or what you would call chips.
Chips, yeah.
Yeah, and that I guess for me, everything was ladder. You had on the left hand side, you had the positive rail, and then the wire went from the positive rail to the relay, and then the other side of the relay was the negative rail. So once you energize that relay, you've got what we call dry contacts, so normally open or normally closed. Not everybody is familiar with that kind of that kind of verbiage, really. But fundamentally, when we speak about programmable logic controllers, it is like that. It's either normally open or it's normally closed. And everybody gets confused between, well, what's normal? Is that when it's energized or when it's not energized? And we'd always say when it's not energized. Okay, so normally it's like fail-safe states when we talk about valves and what position they would fail into in the event of an emergency where we remove all power. Fail-safe state would be either open or closed. So they're two kind of key principles of control systems. Um, but anyway, I progressed on at the age of 19. I did quite well, actually. Being in the northwest of England, I was the apprentice of the year that particular year. And I'm not going to name it because that would give my age away. But at that point, I was put on what they called the fast track. And the company that I was working for were international. They were actually called Balfour Kilpatrick International. And they said, right, we're going to fast track you now. We want you to get experience of all elements of the company, and we're going to send you to Saudi Arabia. And I'm like, hang on a minute, I'm 19 years old. I've heard stories about this place, not sure if it's going to be for me. And they said, oh, don't worry, you have to be 20 to go there. But because you're now a graduate, you can go. They'll allow you to go and work there. So I went to work in Saudi. And from Saudi, there it was oil and gas, gas oil separation plants. And that's where I work with. A lot of the guys that I work with were either European or obviously because of Aramco, the Arabian American oil company, there are a lot of American guys there as well. So I was out there for 9 months, and then the biggest ever explosion fire in the world at that time was at a place called GOS 2, Gas Oil Separation Plant 2, just outside of Abcake. And that was the plant that I was working on. But luckily for me, it went up in the middle of the night. So when we went down for breakfast in the morning to go to work, they just said, no, you're going to have to stay on camp. We're trying to put this fire out. It's ridiculous. A lot of people died, all kinds of things going on. Anyway, they said after 4 days, I think it was 4 or 5 days, we can't get this under control, guys. We're going to lay you off, basically, send you back. So it was like, oh, okay. So kind of a circumstance, really. On the way back, I flew with Sabina Air, which was the Belgium airline, and went through Brussels. So some of the guys have been talking about a company in Brussels that were employing people for North Africa with my kind of discipline, electrical engineer. So I thought, you know what? I'll go see them. I'll have some mules and some frites, as we all know, the delicacy of Belgium. And it just so happened the company that I went to see were an American company called Morrison Knudsen Jarvis, the largest private company in the world. I had no idea at the time, but MKJ, they sent me off to Algeria. So I was working in Algeria, again, as an electrician. And all the guys, I was running the job. So all the guys that worked for me were local guys, but I spoke French. So it wasn't too bad for me. And it was really, really enjoyable. And then MKJ, after I think it was 7 or 8 months, we were doing sea cleaning stations in exchange for gas that was coming out of the Sahara. They said to me, we've got a job that you'd probably be interested in over in Detroit. And I'm like, okay. So, because I was a big Motown fan, so Motor
Okay,
City.
Motown.
Yeah. And that's on a personal note, which I will talk about later on. I was a massive fan of all of the Motown artists. Anyway, I went over to Detroit, and whoa, in 1968, a guy called Dick Morley invented the PLC. And when I got there, it was a Modicon 284. The very first one was a Modicon 084, which was the number of the project for the company. I think it was Bedford Associates that Dick Morley worked for. But anyway, I'm in a car plant in America, and there's a PLC. I don't have to install relays anymore. And the guy said to me, well, if you know how to draw a ladder diagram, you can actually now just do it on the fly. He said, just create a coil. It connects to a rack, and you've got as many contacts as you want off that coil. And honestly, for me at that time, having spent most of my time building panels and wiring relays, this was like nirvana. So
It's kind of like
I
when in Wizard of Oz when Dorothy it was all black and white and then she could see in color.
That's exactly right. That's a great analogy. And for me, because I had a really good grasp of control systems and what they're supposed to do. And I was also very aware of at that time the safety side of things. So what we would call immediate interrupts or ultimate switches. That basically, if things got out of control, a big old switch would just remove all power. And it goes back to what we were talking about earlier, fail-safe state.
Yeah.
What's it going to fail to? So I then went from working in Detroit, I went back to the Middle East and I went to Iraq. And then I went to Iran. And then I went back to Algeria, but working in the Sahara on gas pumping stations way down in the desert. Again, lots of different nationalities of guys that I worked with as as I progressed in my career. Well, by the time I'd finished working away, I came back to the UK, and nobody really knew about PLC at that point. So I was in a great position. The British steel industry are now moved into steel because they were automating, because the Koreans were producing a kind of steel that we couldn't compete with at the time. We needed to improve the way we did things. So guess what happened? They sent me to Yugoslavia. Yeah, I know. Well, the former Yugoslavia. What a beautiful place. You know, I was there working on automating steel plants over in Yugoslavia. So my career has taken me all the way through from the
Yeah.
beginning of programmable control, right the way around the planet to the point where I worked in all of the major verticals. I was a subsea control system engineer for BP, producing control systems offshore for Exxon, Shell, Texaco, Chevron, working with NASA, because when we were producing these subsea control systems for 10,000 feet, because all the low hanging fruit had been picked in the likes of the Gulf of Mexico and the North Sea, all the shallow water stuff. Everybody had basically taken what they could. And now we needed to go deep water. And to go deep water, they realized that obviously you can't put a platform out there. You're going to have what we knew as floating offshore storage and production, FPSOs, as they were known, with umbilicals coming off the bow of the ship, going down, connecting to subsea modules, which would then control the flow of oil back up to the surface, up to 10,000 feet. So we realized that the kind of pressures and temperatures we were going to encounter were the same as outer space. You know, so that's why I moved back to America. I was living in Houston, working with the guys at NASA. You know, so yeah, we developed the very first one.
I lived in Houston for several years in the north part, the Woodlands. So yeah.
I know the
Awesome.
Woodlands very well. Yeah, yeah. There's a great live venue up at the Woodlands that I used to go to watch.
Mitchell Woods Pavilion.
That's exactly it. Yeah, yeah. So a lot of good bands there. But yeah, like working out of Houston, we developed a company called Cameron Controls, and then they sent me to Germany to the plant where we built the subsea control modules. Because all the heavy stuff, all the heavy lifting, that was all done in Houston. But once we developed the control systems for subsea, now I kind of jumped a step or two here. Because before I went working in subsea control, I worked in the nuclear industry.
Nice.
Yeah, back in the 90s when we first got mobile phones and we had modems for connecting, you know, to get onto the university's type information systems at that time. And I encountered for the first time distributed control systems. You know, oh, it's a DCS, you know, by Foxborough, Yokogawa now, and a big producer, Emerson, blah, 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 distributed control. And I'm like, oh, hang on a minute, distributed control, we do that already. PLCs have remote racks. You know, we run a belt and cable out to them, and that's distributed control. Oh, yes, but these have graphics, and they've got, you know, control room type. Yeah, and they're like, oh, okay, well, fair enough then. So we were basically running cables through modems from our satellite control systems back to the DCS. And the DCS was acquiring all the information. And they had their own sets of screens, graphics for the operators to interface with. But not long after that came a product called In Touch by Wonderware, along with, because at that time, we weren't really using computers in the control environment. And then, because everybody was talking about the Mac, you know, because that was the graphical interface, and everybody wanted to be basically using graphical interfaces and a mouse. But then came Windows. Because previously, all the work that I'd done in terms of programming was done on DOS with BASIC, command line stuff. But lo and behold, Windows 3 came with, or would work with, a product called InTouch from a company called Wonderware, which now invents this. And we could now build graphical interfaces and connect these interfaces to the data that the PLC was producing and have the equivalent of a DCS. So the operators could have their screens, they could see all their temperatures and their pressures, they could initiate sequences at the PLC. So we kind of became independent from the distributed control systems again. And not long after Windows 3, and Windows 3.11, which was called Windows for Workgroups. And guess what? TCP. So now we could, using data access servers, gather data and distribute it. So now we got client server type equipment inside our PLC networks, totally independent at that time from anything else that was going on. IT was evolving, but we were still running on a parallel path, I would say. So we developed quite complex systems, NT4, and then back office. Things evolved very quickly, and the ability then to have control of users, access control. So primary domain controllers and backup domain controllers, and having our guys log in and be able to control access. So just halting for one moment, in around about 1995, I was in the nuclear industry working at a place called Sellafield in Cumbria. And we were at a place that was breaking down and reprocessing fuel rods from all of the reactors around the planet. And one of the byproducts coming out of that was UO3, uranium, and plutonium. And it was my job to write the software for the PLCs that were going to package the dry product that came out of the process. So can't go into too much detail because I'm still, a lot of it's information that we don't want out in the public domain.
Yes.
But fundamentally, I was making cans of plutonium. So, and storing it. So we're all fully automated. Like I was a long way away from where this was going on. But it was really interesting. And believe it or not, the principle of train control now, for example, London Underground, is based on the same algorithms that we wrote for moving plutonium around on a rail system. Same deal. You put something in a zone and that zone's occupied, nothing else can go in there until that particular item leaves that zone. Once it does, in comes another item. So it's the same principle as controlling trains. But it was around about that point. We were using, I think it was Windows 95 was out there. And one of the chief engineers came to me and he said, we've had viruses on our IT systems, like worms or whatever, Trojans. Can we get a virus in a PLC? And I'm like, no, I've seen these viruses. I know what they do because we used to look after the viruses on our own machines. They were prevalent at that point in time, but completely useless and harmless, very easy to eradicate. I said, no, you cannot. A PLC doesn't operate in the same way as an operating system, be that Linux, be that iOS, or be that Windows. Somebody would have to specifically write a piece of software. He said, well, can you do me a favor? If we think something's not right, would you be willing to have a look? Could you organize yourself into, let's call it, what we now know as incident response? And I said, yeah, no problem. Just give me a shout. I'll be out on plant. Lo and behold, about probably 4 or 5 weeks later, I got this urgent message. I was actually not at work. I was at home. Can you come back straight away? And I'm like, okay. Yeah, we got something not right here. Something, we think it's a PLC virus. And I'm like, oh, shoot, okay, all right. Which system? Because I've got a lot of systems. They told me, and I came back, and they were calling it the ghost in the machine.
Mm.
Yeah. So I have a habit when I'm writing code of like initially, I'll always write at certain points within the code when you reach a branch, should we call it, I would write to a log file because you could, so you write a little message to the log file. If it was a Windows system, I'd put them in the system log. So I started looking through my logs, and I couldn't see that there was anything wrong anywhere. So I started looking at what was actually happening, and keep it as short and sweet as I can. To start a process, you push a button on a desk, so the operator pushes a green button, basically start process. And that green button only works when all of the prerequisites are there, the interlocks as we know them. So is this door closed? Is this pressure low? And so on and so forth. Is the flow rate right? Typical process. So that I looked and I could see that there were the interlocks, they were all good. But when I looked again, the actual contact that we spoke about very early on, normally open, it's a push button. But hang on, it's closed. So I went to the control desk and I said to the guy, like, I'm a qualified electrician. I said, we just need to power the desk down so I can have a look. And I went inside the desk, got hold of this button. Guess what? Mechanically, it was stuck in the down position. But I give that analogy to people as an example of how people are very, very quickly jumping on false positives, shall we say, without thinking about the control system itself and what its function is and what interlocks it has. And who knows? I'm sure you're aware, we do get bugs coming out in code, sometimes take 2 years. Depends how many times that piece of code gets executed. And if all the planets align, and the other one you have to watch out for, where there's distributed control systems, is those other systems have unsolicited write access to your memory locations. And if they've got a bug in their code that's pointing into your memory that sets a flag that triggers you off, and you're not monitoring that, that's going to look like a cyber attack right off the bat, and it isn't. So I know that whenever I approach an incident that's deemed to be a cyber attack, I need to see all the logs. Mm-hmm. It's kind of it's forensics, shall we say?
Yeah.
I need to know who was operating the plant at that time. When was this a normal operation? How was it started? So on and so forth.
Yeah.
But
I mean,
that comes from
that's the early incident response. You mentioned that you kind of got introduced at the early onsets of them developing incident response plans, right? And you mentioned default safe or fail safe. And another thing you mentioned there was, like you sometimes the most likely probable calls, you have to eliminate all the common causes first before you go up here and say, oh, we're being hacked and attacked. You got to eliminate all of the most probables. So I love the approach because it's very pragmatic and it makes logical sense. I love the fact that you've been so many countries around the world. You got a lot of experience with different industries. You mentioned big ones like nuclear, and you mentioned like the forefront of PC computing. You said Windows 3.0, which takes us really back. That's back when we were transitioning from these floppy 5.25 to 3.5 inch floppies like this one. Most people nowadays watching this sees, hey, is that the save icon? Yeah, it's a save icon, but this is also a floppy disk. And like when you mentioned Windows 3.1.1 and like eventually Windows 95, I think it took like 40 something disks to do an install. So
You've
yeah.
been there. You've been there. And we all went through that learning curve, and we were not gung ho, because I learned, especially being in nuclear and pharmaceutical, I worked with Glaxo as they were there on their plants for a while, that there are regulators involved, and there are procedures and processes that you should follow. I was a big fan of the IEEE as we know it, and they were the first organization, certainly in Europe, to produce the software lifecycle documentation and what I know as the V model. So when I talk to people about it is a tricky one, Jim, because like when people come to me, and I should point out that I facilitate for SAMs. So, and the reason I facilitate for SAMs is they were the first organization that I went to when I realized I needed accreditation and certification. I can't just call myself a cybersecurity engineer. I need training, and it's not cheap. I also went to the ISA and started on their IC32, IC33, IC34, IC37 cybersecurity expert. There's my concern. I don't want to go off piste here, but my concern was being recognized for your skill set. And so many people nowadays struggling to know, what should I learn first? How can I get into this other side, the dark side, operational technology? And it can be quite dark. I mean, it's dangerous. It can be very dangerous. And we won't have time to touch on it here, but believe it or not, that Deepwater Horizon disaster out in the Gulf of Mexico, I was out there on that one. And the reason I was out there on that one was because that vessel had a sister vessel that we'd fitted out down at Galveston, another drilling vessel. And we fitted it with a subsea control system, and we'd been commissioning it. And we were about to go and fit out the vessel that had all the problems out there just off the coast of Alabama. And I'd written a report, site visit, shall we call it, where you go to the vessel, you have a look at the control room and access and where we're going to put the cables and where we're going to put our control system and the reeler, because we have to have reelers that fit on there. And don't know how familiar you are with drilling vessels and subsea controls, but down at the wellhead, we have a LMRP, a lower marine riser package. And on that riser package are shearers, which shear the riser if the dead man, which is the safety system, says, I've got no comms or I've got no hydraulic pressure down here. Or any situation where you're not controlling that wellhead anymore, you shear, you seal it. Yeah. And I said to them, on this particular vessel, if you're going to run 16 or 18-inch riser, the accumulation you've got on that LMRP subsea doesn't have the oomph to shear the riser. So, when we do the work on this particular vessel, we can update that for you as well. Not long after that, I headed back to the UK. When I was back in the UK, I saw on the news about this incident in the Gulf of Mexico, massive fire, blah, blah, blah. Then I got a phone call from London from somebody at BP who said, I've just seen a report here that you wrote about that particular vessel. They got it on hire from Halliburton or Transocean, I can't remember. Would you be willing to come and meet with us and we can discuss it further? Obviously, at that point, it was going highly legal. So I ended up working for BP. I went back out to the Gulf of Mexico and was part of the, basically what was the recovery team. We were dropping heavy mud on trying to get that wellhead sealed. But I was back on the vessel that I'd fitted out. We were out there it took about 10 weeks in the end. But yeah, dangerous,
Yeah. And they made a movie too about that incident, Deepwater Horizon, I believe, with Mark Wahlberg and a lot of other stars were in that movie. So wow, what a moment of history that you was coming in, giving, about to put in a updated solution that would fix the other equipment's the thing that actually caused the incident. Wow, how close you were to that.
And yeah, absolutely right. And like I'd been out commissioning on the original vessel, and when you're working offshore, you have good days, you have bad days. But what you're reliant on is the instrumentation that's telling you what's going on there, the flow rates, the pressures, the temperatures. And I think the mistake that was made at the time was there was a faulty instrument. Now, in nuclear, we always have, depending upon what we're trying to avoid, in other words, what we want to mitigate when we're mitigating risk, that we don't want the consequence to be damage to the environment, death. Forget about reputation for the moment, because once you damage the environment or kill somebody, your reputation's shot at. So that's what we're looking at with BP. Obviously, their shares took a deep dive, and it's the one thing that you're always conscious of. Like, I work with 12 megawatt DC drives, and if they go wrong, you don't want to be around. Never mind oil and gas. Big DC drives in the steel industry, and I've seen we had to demonstrate that we could break the circuit on a 12 megawatt DC drive when it's at full speed, and the circuit breakers are massive. But when we opened the circuit on the breaker, it just melted. There was a massive arc, unbelievable. It was all melted copper everywhere, and it's like, oh my God, electrical flashovers, very dangerous things. And you do learn over time, and I've seen the consequences of you not operating safely. So I always say to people, like, if you're coming into OT, make sure you've got all the PPE you need and you've done all the training safety wise, and especially if you get the opportunity, offshore training.
Oh, sure.
That's there's the survival training you do where they dump you in the water in the dark, in a wet, in cold seawater, in a helicopter, and turn you upside down, and then you've got to get out.
Well, I mean, you got to be ready for when the real thing happens, right? So I just want to,
Absolutely.
yes, I want to interject just a moment, because for those that's watching up to this point, Tony here has covered, really just a summary of really the highlights of his career, right? He's mentioned Deepwater. He's mentioned, working with nuclear programs. He's worked in various countries. But the key acronym he said, and you didn't hear it wrong, it's OT, not IT. So IT, we all know, is information technology. OT is operational technology. So earlier he was talking about programmable logic boards, PLCs. And some folks out there might have heard of the PLCs, because recently, in the past I would say 8 years for sure, one of the top 5 concerns for IT cyber within Capitol Hill and Washington, D.C., that's being discussed is industrial control systems. You might also hear another acronym referred to as like SCADA systems. But these are systems that are automated systems that do various functions that they're programmed to do, that we don't always consider as part of the IT infrastructure. Like IT, we think of our laptops or mobile phones and computers. But these are the other side of operations, such as like when we hear of the IoT, Internet of Things. That's really OT, operational technology. These are like the sensors. When you think of like a chemical plant, and all of these, you'll see, from the highway or something, if you drive by an oil plant or oil, gas, petroleum, or chemical plant, you'll see all of these silos and these stacks of smoke and various things going out into the atmosphere. All of these things, there's pipes, there's all kinds of things that have pressures that have to be monitored, not just to 1, 2, 3 zeros past the decimal. Sometimes engineers want them 10, 15 spots behind the decimal, because that matters when you start getting into very discrete kind of mathematics, when dealing with different pressures, and how slight fluctuations in pressures could be an indication of either having to tail down, like pull back the process capacity output, or maybe increase it depending. And there's multiple systems on top of systems. So the complexity of this gets really out of hand really fast. And it takes really smart guys like Tony here to help assist with that process, because he's the one helping them program these controllers and things that will help the engineers be able to not only control, but to also monitor what all of these various things and data inputs that are coming in, that help managers, help engineers make decisions that could, if they get it wrong, whether a controller stops functioning, stops doing the function it needs to do, and it starts a domino effect, or rather like a drop in the lake, a ripple effect that could be a really bad thing really quickly. And so when he mentions the environment and human life and safety, we talk about this sometimes in cyber when we talk about disaster plans and so forth, but not as, it's important, yes, in IT, but it's most critical in operational technology when we're dealing with dangerous chemicals, dangerous processes, and things that are highly pressurized or highly volatile. We get into the world of, the chemical, pharmaceutical industries and all these processes. At some point, they're going to come across very special type of chemicals or byproducts. Things such as one of the dangerous things in chemical industry is oxidizers. And oxidizers, for those that don't know, is a chemical that it reacts to oxygen. So that means if it gets out of its containment, whether it's in like a ball, a pipe, or whatever, it's going to go boom. It's going to, ignite and go boom because it's oxidized. And then we have other chemicals that are deadly to breathe in. So if it releases in, it could catch wind and take out a whole neighborhood or two that's next to the facilities. So all of these things is really heavy and important, and it's heavily regulated. He mentioned OSA, Occupational Safety Health Agency. There's other regulatory agencies that ensure that people are properly trained to work within these facilities, to work within certain areas of the facility, and there's all sorts of very specialized training. So Tony has got I would say, an encyclopedia of experience in not just one particular industry, several different industries that all have their separate sets of regulations and controls to keep them as safe as possible for both the world environment and human safety. But what I really want to get to, Tony, is again, I know we could talk for days and days about all the stories you have, but you already mentioned Deepwater Horizon. But one of the things that I want people to really get from this podcast is really, they hear IT and now they're hearing about OT technology. But I think, is there another story you have where, like the Deepwater, I think it's a phenomenal story, like how you was about to solve the problem that ended up becoming the risk that the reason why you was replacing that system was because of the risk of what it could do, and it actually did do that. That's a phenomenal story by itself. But do you have another story that you could share with us that really drives home why OT security and the controls that are around it matter?
I think rather than talk about my experience, I think if I talk about, because I've been in a few situations, but that will be another day. As you say, we could talk for hours. But if we talk about cybersecurity, I think the prime example of what brought all this about is Stuxnet in 2010. So, and I think now it's fairly well documented, and there's a great documentary on YouTube. It's about an hour and a half long, called 0 Days, accessible by everybody. Well worth a look. It's better than some of the films you're ever going to see. Yeah. So I was a member, and still am, a member of a forum called control.com, which was controls engineers. We used to go in there and have some banter and talk about all kinds of stuff. And I was in that forum in the middle of the year 2010, and somebody dropped a note in there. Oh, has anybody been approached by any of the guys from Kaspersky? And I went, Kaspersky? Sounds like a chess player. Who's that? So we had a bit of a chat. And then somebody said, have a look at this. There's a piece of code here that they're asking about. Does anybody know what it's doing? And probably within 2 or 3 minutes, we went, whoa, that's looking for a Siemens PLC with Step 5 software. And it's targeting the IP address. Who's doing that? Well, again, you watch the 0 Days documentary, you'll very quickly realize who was doing it. And I get it. I understand that we go right back to, 15 years previously, I've been talking about it. Can we write code that will basically disrupt an automated process, which is run by a PLC? And yes, of course you can. We knew you could, yeah? But fundamentally, when you're controlling a process, you have set points. Now, in this particular case, it was a centrifuge. And it was doing, I knew all about it because this was UO3. Centrifuges spin out and they have a certain speed, which then separates certain materials so you can get all the bits you want. This particular cyber attack was at a place called Natanz in Iran. They were spinning out uranium to create the right level of enrichment for what they said was and we'll go with that for now. There's going to be one of their energy programs. But we also know that what comes out of that particular enrichment process is nuclear grade, weapons grade. So what are they going to do with that, I wonder? Anyway, when you're spinning the centrifuges, you spin them to a set point. And what had happened here was this particular piece of code, this cyber attack, was modifying the parameters, the set point, but kidding the end user, the operator, at his human machine interface. He couldn't see it. Didn't everything look good? All of a sudden, bang, the centrifuge would just blow itself apart. They destroyed nearly half, I think it was around about half of the centrifuges. The Iranians thought it was internal sabotage, what we now know is insider threat. And some people died. And again, you'll see from that particular documentary that paranoia, especially in nuclear, when things go wrong, everybody looks at everybody else. You know, we know this, blame culture. You know, it goes down to the simplest level of communication. You never told me. I did tell you. When did you tell me? How did you tell me? You know, so this, it's what switched me on. It's happening now. 2010. It's happening. You know, and I knew from my experience at that time that everything now is well, it's prone, it's vulnerable. And yeah, we use the term common vulnerabilities and exposures, CVEs, in the cybersecurity industry. We talk about CVEs, we talk about CVSS, common vulnerability scoring systems, MITRE attack framework, and so on and so forth. The industry's full of buzzwords. Yeah. I had a really interesting conversation with a couple of guys. I go to S4X down in Miami every year with Dale Robley and all of the guys, and it's now become massive. But anyway, I was talking to a couple of guys from Carnegie Mellon who'd come up with another way rather than using the standard way. They were thinking outside the box. That's what's good about the conference that goes on in Miami, because it's all OT guys. And it's all OT guys who just talk work, or it's not really work, it's an obsession.
Yeah.
You know, because there's so many facets to
Passionate.
it. And so many things. Yeah, you can learn something new every second, not just every day, but in these particular situations at a cabana, after you've watched presentations all day and now you're having a beer and chatting to your peers, some of the stuff that comes out is absolutely brilliant. You know, and we're forever inventive. And that to me is what appeals to me about the industry as a whole. You don't have to be a trained electrician, you know, you don't have to be an electrical engineer, mechanical engineer, a process engineer. You can get into it very, very quickly. And what we like is open minds. Don't think about somebody thinking that you're not an expert. Nobody's an expert. By joining together, I love working with IT guys. You know, I love talking to guys who know about network segmentation. I love software-defined networks. But I'm no expert. I know how to configure a firewall, but I know guys who can configure a firewall while they're asleep. So you make the best use of all the resources that you've got, and you work as a team. And that's the key thing for me, is don't put anybody down just because they don't appear to have the attributes. Everybody has them. It's like the neurodiverse approach, where, you know, on the spectrum, you know, where's your head at? If you ever watched, what was the film with Dustin Hoffman, where he's autistic? Rain Man.
Yeah.
Rain Man. Yeah. Find yourself a Rain Man, because those guys are absolutely brilliant. Yeah. I'm just your standard run-of-the-mill engineer, but you need all of these different approaches to get the solutions that we're looking for all the time. So it's not really a job, you know. It's just a continuous evolution of a game that we're playing, and everybody can be part of that. And we know, as you well know, we're short of people anyway.
Yes.
globally with short people. Yeah, but it's become one of those, how do they describe it? I can't remember the term now, but gatekeepers,
Yeah.
people who won't let you in. Oh, you don't know. I'm an expert. Go away. Yeah, get rid of the gatekeeper. Open the gates and let's all get to it. Because I know I've been on courses, and I can tell you for a fact that there are people on those courses who really shouldn't be there. That's the other side, the threat actors. Yeah. And they're learning from us. Yeah. We need to do the same. We need to learn
Yeah.
from them. It's a game, essentially.
I like
Capture
to
the
tell
flag.
people it's like the ocean. You're on the beach, right? The waves are always going to keep coming, right? And it may
Yeah.
seem, if you look at it from a pessimistic, negative viewpoint, that, well, what's the use? I'll just throw up my hands and give up. But the reason why we have professionals, we still need more people. There's a lot of shoreline, right? On the
Yeah.
threat
Good
landscape,
point.
there's a lot of shoreline that we need to protect, and it's all of us doing the good fight. And I love what you said, where there's always every second there's something you can learn, whether from your colleagues, your peers, yeah, and people, even new people coming up in the industry, some days they're like, "Hey, did you know about this? Hey, I just read this." Sharing information, because I tell people, like for myself, no matter how high of a knowledge base or what certifications I have, et cetera, or how many years experience I have, that's the beauty of our industry. There's always something new. Every day is like 100,000 new apps and LLMs and everything just every day coming up online, and we never know what's going to make the big mainstream or not. But there's always opportunity to learn. And so what I tell people is that, yes, I may be, by some folks consider me a multi-domain expert, but the better term I like to use for myself is a perpetual student. I'm always going to be a student of cyber and learning until the day I die. And I love that you said that about how you just like to learn from your colleagues, even if it's just over a beer. And that's sometimes the best way we learn and get new ideas, is having those conversations that are after the conference. So I really love that aspect. I know we could talk a lot more, but one thing I wanted to kind of let people know about, what we're dealing with when we're talking about industrial security controls, ICS, ICAS, and SCADA, and all of these acronyms that kind of can get confusing in a minute. Could you give us like an example? Because there's lots of stories we talk about. Like I know there was a weapon systems in Turkey that was interconnected to the internet, and so a weapon system technically, as an OT system, should be what we
Yeah.
consider a standalone or isolated or cryptographically isolated type network, right? But in this particular case, somebody had interconnected an endpoint to the internet and therefore bridged the security of the network. Therefore, an attacker was able to come in. They didn't know what they were looking at, because it wasn't the typical databases or data that they would see on a typical server network environment. And heaven forbid, they actually had root level access to that system, to include the subsystems, which they could have forced it to self-destruct, to launch a missile, etc. And it was just amazing that they didn't realize what they were in, and two, luckily didn't prod around too much. But could you maybe just kind of let people know that this stuff is real? Like with more and more OT and IT networks having these, what I call, interconnections. And granted, yes, they may have gate walls and firewalls and DMZs and segmentation and SDNs providing that logical separation, but there's still risk involved. And you mentioned earlier about doing a risk assessment, doing mitigations. This is stuff we talk a lot about in risk management, like NIST RMF, and I know there's a couple RMF things that you're very familiar with in the work you do. But really, the question I have boils down to this: if one was like, "Well, why is this so important?" We already talked about deep water and like weapon systems that could be compromised. But from you as what I would consider a level 99 expert, what is that word you would give to someone? Let's say it's just someone that's in management leadership, to someone that's just trying to learn more about this. What's the message of how crucial is us getting OT security and ICS security right in our today and our near future?
I think my answer to that would always be control. Once we lose control, that's why they're called control systems. So the fundamentals of control is it's closed loop. You don't, we talk about AI at the moment, and I could go on and on. That's a whole separate other topic. But in terms of AI and how long it's been with us, the first fundamentals of AI, although they came around in the 50s, 55, I think, It's been going on forever. But an operational technology control system is AI. By definition, it makes decisions autonomously without the human. Yeah, I've written lots and lots of code that's intelligent in its own right and learns. So I'm watching flow rates and I'm adjusting the openings on choke valves and so on. And it's all happening automatically, tuning. So what I would say is understand even the elevator that you get in when you're in a building, that's a control system and it responds to signals that you give it. But ultimately, it has a hardwired system at the top, which says, if you go too fast, I'm going to shut you down. It's called an ultimate. And that's hardwired in. And we go right back to the very beginning of our conversation here, where we say, what happens if you turn the power off? It's like when we try and shut down a production system in oil and gas, we try and do it with level control. So close this valve, then wait, see this pressure drop, then do this. It's called that you've got levels of shutdown, level 1, level 2, level 3, etc. Well, bottom line, we've got crash shutdown, which just says power off. There's no humans left in the control room. The halon gas has gone off, everybody's dead. That's when the dead man comes in. So control, that's what I bring it all back to. If you write the code correctly and you test it correctly, and by that I mean not just positive path tests, do some negative path tests, do the unexpected to your control system. You'd be shocked. Because when you build software, when you design it, you always assume you know what you're doing.
Yeah.
I'm sorry, but no, you don't. Bring in another team to test your software. Don't test it yourself, because you'll always go positive path. Yeah. I used to use the women who clean my office when I was in the nuclear. I used to say to them and their supervisor, like, we're finishing at 6 o'clock this evening. Your girls are coming in at 6:30. I'd like them to spend an extra 30 minutes. Here's the control system, and I just want them to just use it, even though they don't know what they're doing. And you know what? The number of bugs we found was incredible. So letting an uneducated user, as some people might say, onto your control system reveals a lot of flaws that you hadn't even begun to think about. So they do what we call the 5-finger spread, where they basically just hit the keyboard.
Hit all the buttons.
Yeah, and you think, oh, I'm checking everything. No, you're not. Down goes your system. So control.
Control. Trust but verify. I love it.
Yeah.
So I like to segue and thank you so much for all of this information. And then again, we'll have to have you back at another time to kind of deep dive the security controls and principles and things because I know there's so much more. We're barely touching the surface, but due to your time being precious, I do want to go into another part of the interview where you kind of already gave us a quick summary of like your highlights of your career, but this question I love to ask all my guests. And if we go back in time to day one of a very young Tony that just the world was his oyster and he before he started traveling the world, what was day one when he said I want to study, and in your case I believe it was electrical engineering, so what was the story that said I want to be an engineer?
Yeah, quite simple, that one. In reality, it was the only job where you got paid straight after leaving school and your education was paid for. So for 2 days, well, it was one day, what they call day release. One day a week, as part of my job as an apprentice, I would be in technical college. And then one evening a week, I would be doing a bridging course. So I was getting paid and I was being educated. You
Can't
know,
beat that.
oh no, absolutely not, because the guys, my peers, because I went to an English grammar school, which was kind of another level up. You took an exam when you were 10 years old, and if you passed it, you went to grammar school. So it's fairly privileged. So like all my peers in the grammar school education stream, they went on to do degrees in mathematics and biology, and I still drink with them now. I see them most Christmases, and like they always look at me and go, "Wish we'd have followed you. You've been everywhere. you, you've lived in China, you've lived in Vietnam, you've lived in North Africa, West Africa, America, you name it, I've been there. And I said, yeah, it's been great. And do you know what? People were paying me to do that.
You know, it's the equivalent of being in a nice restaurant and you don't know what to order, but you just pick something on the menu. And then the whole time you're waiting for your food, you see all the other people's orders going, what's that? What's that? I should have got that. I should have ordered that. That's kind of like what life is when you get to a certain point where you're like
Yeah,
20, 30 years into your career. People are like, I should have did what you did. I should have had what you were having on the
yeah.
menu. Tony, I love to do the speed round, and it's something I like to do with all my guests. It's just for fun and levity. There's no right or wrong answer. So if I put you on the spot, just whatever comes to your brain first, it's no right or wrong answer. Okay. So we're going to start off with cake or pie?
Pie. I'm English. We eat pie.
Pie. What kind of pie, if you don't mind me asking?
Yeah, steak and kidney.
Steak and kidney. Oh, more of a earthy, savory type of pie. I got you. All right. So we got Star Trek or Star Wars?
Yeah, I saw that and I saw, you know what? It's gonna be Star Trek.
This the engineer in you.
Yeah,
So
exactly
Scotty's
right.
your man, right? The
Yeah,
engineer.
exactly right.
What has been your most favorite book of all time that you've read, and what has been the last book you read?
And my favorite book of all time is still One Flew Over the Cuckoo's Nest. You know, it just because of the way it was written from the Indian's perspective. And you know, and you don't get that when you watch the film, it's different.
Yeah.
Yeah. It's a great film as well, but the book, very, very insightful. And the last book I read was on a recommendation, and it's an old book called Marathon Man.
Oh, okay.
Okay, now that begins. There's also a movie about that with Dustin Hoffman again.
Hmm.
We mentioned Dustin Hoffman earlier in Rain Man, but yeah, Marathon Man, and it's very similar to the way that One Flew Over the Cuckoo's Nest was written, in the sense that for the first 50 pages, you don't want to read it. You're like, what's going on? All of a sudden, bang, it starts and it gets going. So the way that that begins, and this is the way that the film begins, is this guy is he's being tortured. He doesn't know why he's being tortured, and the guy who's torturing him just keeps saying to him, because he thought he was going to the dentist, but this guy is doing horrible things to his teeth. And all the guy will say to him is it safe? And he's going, I don't know what you're talking about. And then he's torturing him. Is it safe? So anyway, it's a great book.
Yeah.
Rain Man. Not Rain Man, sorry, Marathon Man.
Yeah.
So yeah, last book I read, Marathon Man.
Awesome. You know, speaking of books, and you're from Wales, and when I was a child, and it's still in my heart, there was a Chronicles of Prydain, and I think I'm saying that correctly, Prydain. It was written by Lloyd Alexander. I don't know if you're familiar with this author, but
No, I'm not. Yeah.
he won the Newbery Medal a long time ago. But this story he took from Welsh mythology, all of these Welsh myths and stories, and he integrated it into this series. And there's like five books in the series. It's like the Black Cauldron, the Castle Lair, High King. There's five books in here. My brain's dropping the train of thought, but beautiful series. And but yeah, it was largely based on Welsh mythology. And of course, I mentioned I already been to Wales once, and I look forward to going again. It's such a beautiful country. Before we wrap up, there's a couple of things I did want to ask for the viewers at this point because they heard a lot about OT. Do you have any visuals or information or even websites that people wanted to go to learn more about OT, ICS type of controls that you could recommend?
Well, I'll just share my screen,
Okay.
and yeah, and everybody can grab the URL and go and do this themselves. So if I go to, there you go. I don't know if you can see that.
Let's see, it's coming in. Let's see, there we go.
So if you look there on the URL, Dalton-NRS,
Yes.
manchester.ac.uk,
Okay.
accessible by everybody. So I'll just fire it off. Let's go day 2. There you go.
Oh,
It's a fully
wow.
working simulator. And you would have over here on the right hand side, you would have control.
Hmm.
of the reactor core. And what we're trying to do here is keep this particular process inside the correct parameters. So the reactor core is dealing with the reactor rods and lifting them. And when those reactor rods then encounter the water that's passing by under high pressure, generates steam, which drives the turbine down in the bottom right.
Mhm.
So just take note, and if everybody goes and just has a look at it, it's a real-time simulation of a
Wow,
nuclear.
this is excellent. Use. Okay. And so it goes by the seconds here I see over here and the power output, and I guess that looks like MW megawatts. Wow.
MW megawatts, yeah. So I've just adjusted the steam generators there to keep me inside the green zone.
Yeah.
So that's you'll be able to do this yourself.
Nice. I like this. So for those that are watching, I will make sure that that URL is in the description below. This is amazing that you are able to, in real time, see how all of these systems and components, rely on each other. You make an adjustment here, it makes something happen over here. Something happens over here. You have to tell back. This is a very, I still say, and I'm going to maintain this, Tony, correct me if I'm wrong. This is still like I would call this a high level view still, that there's still much more complexity, but this gives you a good like dive into systems relying on other systems, like one reaction and chain reaction, etc. I think it gives you the mindset you need, but to understand that this is maybe one of maybe of 100 other systems like this, all having to working complete cohesion, if you will, to perform optimal functions.
Agreed. Agreed. And as you can see, we're adjusting the steam generation. If I
Mhm.
want to crash this, if I take that right up, now we get the alarm, and you'll see I've got the rods fully raised, generating too much heat. The system's going to crash. But if I bring the rods back, you should see
Yeah, I see
now,
everything coming back to the green.
yeah,
Okay.
there
Oh,
you go.
yeah. Reactor trip.
Yeah, so you can see you're getting real time effect here. So it just gives everybody a good impression of how um, what a control system looks like to an operator in a nuclear plant. That's the kind
Wow.
of graphics that they're going to get.
Well, Tony, I love that you shared this with us, and this is amazing to give people, the visuals on this and the understanding of it. Is there any other sites or resources you'd like to share?
There's only one, and that would be a very simple one. Is SANS, SANS. It's free to join. They just want your email. The white paper's there, unbelievable. There's a forum, there's a community. I'm not saying anybody can afford to do the training because it's expensive,
Yeah.
but it's as access to resources, SANS. And the other one that I always recommend to everybody, it's now it's yeah, it's now really, really usable, is the National Cybersecurity Centre in the UK. Very similar to what Idaho National Labs do in North America. But if you go to the National NCSC, National Cybersecurity Centre.uk, yeah,
Okay.
there again, free training. Like I send a lot of my I get a lot
Free.
of contacts from people and they say, where do I begin my training? I said, just be very careful because it's a bit like Alice in Wonderland. Don't go down the rabbit hole, right? Go with the intent of just wandering around, having a look. It's a bit like going to an art gallery or a museum. You'll see lots and lots of stuff, but don't think you're going to become an expert on day one about
Yeah.
Matisse or Van Gogh or whatever. You're not. You find your way in and you find your niche. So
Yes.
just take your time, no rush.
Well, Tony, if you would, after this conversation, if you would just type those links and send it to me on Messenger, I'd appreciate it. And
Yeah,
before I let you go, though, I do want to ask, I know you do a lot of work in industry. I mean, and you've been in so many events and in the timeline that it's amazing. And I thank you for your work in the industry, because it's folks like you that make our world a safer place. So thank you so much for being a part of the industry as you are and still are. But I would like, if you know, a lot of times besides our day jobs and our consulting work, a lot of us also give back in different ways. So are there any other nonprofits, volunteer work you do, or charities that you support, even if it's just financially, you might send a check every year, that you'd like to highlight at this moment in the podcast?
Yeah, fundamentally, because it's affected the family, it's cystic fibrosis that I support. And I've still got good enough legs to do marathons and go running and do all of the things that raise funds for it. It's an under resourced um, area that, for, as we well know, I mean, the way that the pharma industry works, the pharmaceutical industry is, if there's money, then they're going to create a drug. Quite simply that. And I understand that business model. So some areas of I'm not going to call it a disease. I mean, it's something that happens in your DNA. What I'm really, really interested in at the moment is the fundamentals of the gene research that's going on, and something called CRISPR, CRISPR. Fascinating stuff. And I know that the lobbyists on the farmer side know it's a bit like, it's a bit like the oil and gas industry. When we find alternative sources of energy, they'll fight against it because obviously it's their business, and they don't want everybody moving over to non-carbon type fuels. But yeah, cystic fibrosis, that's the one I support.
So what I'd like you to do, Tony, is please send me the donation link to the foundation or organization that people can donate to. I myself will make a donation from TopCyberPro.com towards that in your name and honor. And folks, I implore you, this, cystic fibrosis is something that does need more funding. There's so many worthy causes out there, but this is one that you don't hear about in the news or TV a lot. Not a lot of celebrities are, sponsoring and talking about it, because it might not be the thing that's affecting them or their families or friends at the moment. But if you're watching this, if you got anywhere from $1 to 20 to, hey, if you got $100 or more that you could donate, we will have the donation link by the time this comes out on YouTube, but the link will be in the description below. And again, whatever your pockets can give, Tony and I will both appreciate that. And thank you, Tony, for sharing that and putting a spotlight on a nonprofit charity that deserves so much attention. Tony, again, I know we could talk for hours, but I want to be respectful of your time. But thank you for sharing your story, little highlights of your career, letting, just kind of a reminder of something that has been talked about a little bit. And we hear every now and then, about once a month, I'll hear a major story talking about our water treatment plants, our regional electrical grids being under potential cyber attacks. And we've had a couple of cyber attacks, or I'm sorry, rather ransomware attacks that have happened in different industries and sectors in the US, and some that we probably never hear about globally, because a lot of folks don't want to admit something bad that's like that happened for purposes of stocks dropping down and tanking. But this is a very important facet, and I'm glad that I've had Tony on this, and I hopefully will have some more folks on as well to talk about OT, ICS, and SCADA security controls, because when we think cyber, we usually don't think about OT and SCADA and ICS. We usually think about our networks, firewalls, and penetrations, but we don't understand that that's not the only place where attackers. Denial of service is about physical destruction. And Tony talked about Stuxnet being the world's first cyber weapon. And Stuxnet was a true denial of service attack, because its intention was to physically destroy the infrastructure or parts of that process, to delay it. The target goal was to delay that program by years. Unfortunately, it only delayed it by months. So it didn't meet its full intent, but it did show that it could touch it. And the fact that it showed that you could take malicious code and touch something which for the longest time, for decades, people thought was untouchable and didn't really worry about it. They worried about all this new stuff they were creating with Windows and all these servers and systems. They put all their money and attention here, but they forgot. They relied on what, just old thinking that, oh, they'll never attack that. That's just logic, ROM chips, and etc. Programmable chips that are, don't really have RAM memory. They kind of negated all the thinking of that being a risk. And then Stuxnet came, then Dooku came later, and there's been a couple others that we can't talk about publicly. But the point being is, it's not going away. And so the work that Tony's been there from, like, I would say almost day one on the front lines of this as it grew and grew, like from incident response plans to today, where we do have that interconnections and so forth, which, as he mentioned more than once, these are supposed to be closed networks, if you will, that conceptually they're supposed to be not interconnected to have that additional access to worry about. But, the necessary evil is these big complex plants and facilities need to have the information to where anybody sitting at any desk on the network or any point on the network can view that data, because you can't always put your best engineers into every plant. Sometimes you have a regional engineering office, and those guys sitting in like Houston have to be able to monitor 30 plants across the US or the world. And it's hard. You can't have that kind of intellect in multiple places at the same time. So it's a necessary evil. But as we approach those integrations or interconnections, we have to do the smart things and do like the testing he mentioned. I love the whole raking the fingers across the boards to just see if you can break it test. And we still need the basics. That's, when we think of like pushing all the buttons on a video game controller to try to win the fight, that's the same concept. But you know what? It's effective and it works. And as Tony has said, you'll find out more from just letting, people don't have no knowledge of what they're doing try to break it, because that's the real test, is when you get the guy that's a brand new engineer and he doesn't know what he's doing, pushes the wrong button. You don't want to have a whole shutdown meltdown, but you want to find that out in testing before you go to operations. So there's still basic security concepts that Tony is saying that, hey, we still need to follow these basics while still making sure they're addressing the new stuff coming down. Like he mentioned AI, which we're not going to go down that rabbit hole today. But Tony, thank you so much for your time and your wealth of knowledge. Would like to invite you to come back again in the future, and maybe we could do kind of what I would call the deep dive. But is there any last thoughts that you want to share for anyone watching this that's thinking, well, should I go into operational technology work or not, or IT? If someone's on the fence, what would you say to that person?
I'd say you have to, because, and it isn't, the fact that we're short, globally short of, they're talking about 4 million people, and that's in all aspects of this new discipline. So project managers, uh, technical authors, so on and so forth. There's a massive shortage of people. So it's your opportunity to learn a whole new skill set. And there's lots of people around who will support you. So I would say, yes, OT is the way forward. And behind that, you'll pick up AI skills as well. And you're going to learn a lot more about the environment around you. And you're going to learn about stuff that you never, ever considered before. Think about how an airport works. For example, I've done baggage handling systems down to automated landing systems for aircraft. It's all OT, instrument landing systems. Airports are amazing.
Yes.
And I'm about to go, funny enough, I've got to go down and do a review of what we call the posture, strength, or maturity of one of our major airports here in the UK. And I'll be down there next week having a look at where they are in regards to what their regulator is
Of course,
saying.
it's not going to be Heathrow. That wouldn't be the major airport
I
in
can't really tell you, and I'd have to kill you.
I'm sure it's going to be Gatwick. So anyhow, well, again, thank you, Tony, so much. And look, folks, everything we talked about, including the wonderful link he shared with the training where you can real time manipulate a system or control a system rather to stay within bounds, within the green. I'm going to have that in the description below. I'm also going to have Tony H's LinkedIn profile. If you want to connect and follow him and the great work that he's doing in industry, he's still there leading the forefront in industry. And it's folks like him that hats off to you, man. Thank you for so much for doing the work that you do. It's tremendous work. So thank you, Tony. And man, I can't wait till the next time we have a conversation like this.
No problem. Thanks for the invite, Jim. I've enjoyed it.
All right.